Everybody knows true because that's attendance. Notes are like attendance. So true that I have. So on Friday we'll talk about acid and bases, looking at pKa, and today we will talk about which one is stronger acid, looking at the structure, because structure of compound, structure is telling about reactivity, acidity. So based on structure, without looking at tables, you should make a decision which one will be stronger acid, which one will be weaker acid. So the first, water and methane, which is stronger acid? Methane or water is stronger acid? So whenever you have making like decision like this, first thing you should do is to draw conjugated bases of this acid. So what will be conjugate base of this acid? So for water, I remove the proton, not electron, so I will have iron, and I remove a proton, but not electrons, just proton for the base, so will be CH with negative charge on carbon, because this electrons are stable. The second, then, after then you have to decide which conjugated base is more stable. So which of these two is more stable conjugated base? You have to look, what's the difference? Negative charge on oxygen or negative charge on carbon? Which is more stable? To have negative charge on oxygen or negative charge on carbon? So, more stable conjugated base, because it is more stable to have negative charge on more electronegative atom. And if you look, the size of the atom is not almost the same, not exactly, but not significant difference. So then, the more stable conjugate base, the more acidic the acid. So which of the acids will be stronger acid? So water and methane. So which of these two is stronger acid? So the more stable conjugated base, the stronger the acid. So this is stronger than that. Most stable conjugated base is weaker base. If I will ask you a question, which of these two is stronger base? Which is stronger of these two base? Negative charge on carbon. This is stronger base. Most stable is not ready to react. It's stable, so it will not react. Most stable base is weaker base. Weaker base, stronger acid. And now, what will be the trend in the periodic table if you look within the row? How the acidity is changing, going from left to right? More increase, because electronegativity is increased. So which of this proton is more acidic? Which of this, if you can like put the notes for me, which proton is the most acidic? Yes, the more electronegative atom to which proton is directly attached, the more acidic. So you remember the trend, increase with envelope, increase electronegativity, increase acidity. Now, let's make a decision which is stronger acid, HF or HBr? Which of this is stronger acid? So, to make decision, we first have to look at the conjugated bases of this acid. Conjugate base of the acid are halogen with negative charge. So, which of these two is more stable? We see that this is more stable conjugated base. So this is weaker base, more stable. Why this is more stable? Because the size of the atom is bigger. So this negative charge is electrons are density are not accumulate in one place but spread out. If you spread out the charge, it's more stable. So because of it going down the column, the size of the atom is significantly increased because we're adding the shells. The electron density is spread out, it's more stable. So the electronegativity, if the size of the atom is not the same, then electronegativity does not matter. Just for the atom to which proton is directly attached. So what is the trend going down the column? How an electronegative acidity increase from left to right and then increase down the column because size of the atom increase down the column. So increase size, increase acidity. Now, we have to make a decision now which of these two is stronger acid, a phenol or an acetic acid. So first of all, we have to draw the conjugated bases of this acid. So that's a conjugated base for one, this is conjugated base of the other. And then we have to make, so first, if you have a question which is stronger acid, draw the conjugated bases and then decide which of these two is more stable. More stable conjugated base, the stronger the acid. So which of these two conjugated bases is more stable? Both have negative charge on oxygen. What is the difference here? That this negative charge is localized, just staying on this oxygen. This negative charge, actually that's not a real structure, it's just one contributor, electron can delocalize. So electron will go lone pair electrons will move, and this will go, electrons will go on oxygen. So the real structure is a hybrid of these two. So now this oxygen will have negative charge and will have, so the real structure is hybrid of these two. Electron is spread double, partial double bond, partial negative charge, partial negative charge. So in real structure, negative charge is not just on one oxygen, but is on both oxygen. It's that this stabilized electron localization stabilized compound. So since this is more stable conjugated base, which will be stronger acid, the stronger the acid. So we're okay with this. That's a resonance effect on acidity. Now let's look at this. These are conjugated bases of alcohol. What's the difference here? That's a conjugated base. What is the difference? That here we don't have any electronegative atom. Here, negative charge is on the same atom. Negative charge is on oxygen. What's the difference that we have now electronegative atoms? But pulling these electrons through the sigma bond, not like here, through the pi electrons, lone pair electrons, but pulling through sigma bond, because it's more electronegative atom. So this is called inductive electrons effect. So it's pulling electrons through the sigma bond and decreasing electronegativity on this oxygen, stabilizing this negative charge. So which one is more stable? This is more stable, so the acid of this will be more acidic. I will give you some other example. Which of these two acids is stronger acid? Which of these two acids is stronger acid? What's the difference between these two structures? Electronegative atom is which proton is acidic proton, the most acidic proton here in both of them. The proton attached to oxygen. So during acid-base reaction, proton attached to oxygen is the most acidic, will be involved in acid-base reaction. And this electronegative atom here in the first one is closer to oxygen. So if I will show conjugated bases, I will show like this. So this is closer, this is more far away. If it's closer, have higher force to pull. So this will be more stabilizing than this negative charge. If this will be more stabilizing because electronegative atom is closer, which one will be stronger acid? First or second? Which will be stronger acid? First. So this is stronger acid. What's about which of the two will be stronger acid?
Second.
First of all, what is the difference between these two? What's the difference? Bromine is okay. Is the size matter in this situation? If I will have the reason I'm giving, because negative charge is on oxygen. We care about size of this, where the negative charge is. This size doesn't matter, because negative charge will not be on bromine. So size doesn't matter. But what's important? Electronegativity, how strong is pulling electrons. So which one will be more acidic? Which one will stronger pull electrons? The first, because it's more electronegative. Which of these two is stronger base?
Stronger base.
Stronger acid. Stronger base, that's acid. Stronger acid. This is stronger acid because the more electronegative atoms pulling, so it's a bigger force to pull electrons, making conjugated base more stable conjugated base, stronger the acid. And one more thing is, which of this is stronger acid? We see from this that this is the strongest acid. Why? We have to look at, because must be conjugated base be more stable. So this must be more stable conjugated base than other. The more stable conjugated base, the stronger the acid. So why this is the most stable conjugated base? We have to look on what type of orbital these lone pair electrons are. What kind of hybrid is this carbon? sp, this sp2 and sp3. So which one has higher percentage of s in the orbital? sp 50%. This will have a 50%, 33%, 25% of s. And so we see that 50% increase the s in the orbital, increase stability, because electrons are closer to the center of the atom, holding more tightly. P orbital will electrons more far away, they are more stable because they are more far away. So the higher percentage of s in orbital, these electrons will be holding more tightly and will be more stable. So the more stable conjugated base, the stronger the acid. So it's much easier to remove this proton and very hard to remove this proton, because that's attached to, because conjugated base will be too unstable. So that's a summary. Element effect, and actually the importance of this is not like in a book. Remember this name. Element effect is the most important. If I will have a lot of acid for you to compare, doesn't matter what else in a structure is. The first thing you should look is to which atom this most acidic proton is attached. Most acidic proton should be attached to more electronegative atom if the size is the same. If the size is not the same, but the bigger atom, the most acidic proton. And so if they have all the same element effect, then I look at resonance effect, because electron delocalization is more important than inductive effect. So only if all of them have the same element effect, the most acidic proton is attached to the same atom, then I compare the other things. But first, element effect will make a decision which is stronger acid, and other doesn't matter if element effect is not the same, if they are attached to different atoms. So resonance effect is more important for acidity than inductive effect, And the last thing, we have to carbon hybridization to remember. So the more stable conjugated base, the stronger the acid. Which of these two protons, these two protons are the most acidic proton, two most acidic, because this align structure, we have a lot of protons attached to carbon, but they are not good proton to remove. So these two protons, do they have this, first of all, element effect? Do these two protons are attached to the same atom? Yes. So element effect is the same for these two protons. When I look resonance effect, do we have any resonance effect? Okay, if I remove this proton, negative charge on this oxygen can delocalize on another atom, because electrons are delocalized from unhybridized p orbital to another unhybridized, and all these atoms has unhybridized p orbital. If I don't have unhybridized p orbital, electron will not move. Here, then if I remove this proton and I will have negative charge on this oxygen, electron cannot move, because this double bonded oxygen is separated by carbon, sp3 carbon. I don't have unhybridized p orbital, so my electrons cannot move, because there is unhybridized, there is no unhybridized sp3 carbon. But I have inductive effect. Cl will, oxygen too cause inductive effect, but Cl inductive effect. So which will be most acidic? First or second? First. Why?
Because the delocalization is more important than the
Inductive effect, yes. Because after I remove a proton, this negative charge will delocalize on another oxygen. Here, after I remove this proton, they cannot go because I don't have unhybridized p orbital. I should have unhybridized p orbital for electrons to move. So everybody okay? Why? Yes? Yes? Everybody see this, that if I have, if I will show the, and on this side, conjugated bases. It's not the same, but doesn't matter inside. Maybe sometimes. So this electron will delocalize. So I have a resonance effect. Those electrons cannot delocalize because this carbon here is hydrogen here. So they cannot go to this carbon because this carbon is sp3 carbon, this carbon. And electrons can move because unhybridized p orbitals are overlapping. So the electrons can move from this overlapping orbitals. But this carbon is happy with 4 bonds. This carbon will not accept these electrons. Electrons cannot go here. So here we only have inductive effect. So this is the most stable conjugated base, stronger acid. So this proton will be the most acidic. Okay, and we talk about, so now it's another definition about, another definition of acid and bases, Lewis acid, Lewis base. So those are exactly, those are Lewis acid or Lewis bases?
Bases.
Bases. because they have
Available.
lone pair electrons. And the same basis by this the general definition, what we talked last time, and this Lewis basis are exactly the same basis. Because they are electron rich, they can share these electrons with the electron poor atom. So those examples must be Lewis acids. So what Lewis acid should have to belong to Lewis acid? Yes. So like those that are by other definition acid, they are also Lewis acid. All the acid by other definition are also, because the Lewis acid is electron deficient, is electron poor. So this proton has a partial positive charge, it's attached to oxygen. So this proton is electron deficient. Can you open the door for her? And this proton is partial charge on this positive charge. But here we don't have a proton, so but they are still Lewis acid because boron, 3 electrons around, and boron now does not obey octet rule here. So the boron is electron deficient, does not obey octet rule, can accept electrons. The same here, in the third group of periodic, in the 1, 2, 3, third group, they are electron deficient, this atom, so they can accept electrons. So those are, all of those are Lewis acids, and those Lewis bases. Lewis base is electron rich, Lewis acid is electron poor. Lewis acid can accept electrons. So let's make a decision which of the two is Lewis acid and or Lewis base. A reaction happen only between electron poor and electron rich. If both are electron rich, they don't like each other. If both are electron poor, they will not react. So which of the two will be Lewis base? Because of long electrons. So this is Lewis base, this is Lewis acid, and look, if we will show curve arrow, how the curve arrow, when curve arrow should start? From lone pair, curve arrow should start and should go to boron, because boron is electron deficient and boron will accept this electron. So curve arrow from lone pair going to boron. So now this lone pair electron is a new bond between oxygen and boron, and the formal charges will change, so we have to adjust formal charges. Now boron, more electrons, negative charge, oxygen, 1, 2, 3, 4, 5, but 6 will have positive charge. So let's make a decision here. Which one is electron rich will be Lewis base? Which one is Lewis base? That's electron rich. That's Lewis base. Lewis base, these 2 electrons are going to electron deficient. So this will be Lewis acid. Electron deficient, Lewis acid. And this is Lewis base. This will be Lewis base. This is Lewis acid, this is electron deficient, does not obey octet rule. So these electrons will go to this atom. So how we will draw the structure? New bond between carbon and bromine. These 2 electrons will be new sigma bond connected, these 2 atoms. Lone pair electrons, new bond between these 2. New bond, so everything else without change. Only now bromine, these 2 electrons of bromine are here, sigma bond now. These 2 electrons, sigma bond now, between these 2 atoms that was electron deficient. And we also will be using a lot name nucleophile and electrophile. Phile means love. So electrophile loves electron, and they love what they don't have. So electrophile will be electron poor. They love electrons because they don't have electrons, so they will love to have. So which of this is electrophile?
Acid.
Lewis acid, very good, is electrophile because they are electron poor, they electron deficient, they will love to have electrons. Nucleophile loves nucleus because nucleophile is electron rich. So Lewis bases we will call nucleophile. The reaction only happens between electrophile and nucleophile. Any reaction between electrophile and nucleophile. Okay, group 1. Here are my notes if you wanted to check your notes with mine.
Is there a way can you reach the notes?
Yeah, I can reach that. Just give me a sec.
If you wanted to use this.